Good morning. My name is Lungile, process engineer by profession, teacher by hobby. Welcome to my design class by design for students. Let's build a process design package together. The aim is to bridge the mental gap between what happens in real industry versus what you think happens based on varsity experience. By making the design process real for you as a student, I hope to unlock your potential to ace your design course this year. Before going into our mock design, let's discuss what chemical engineering looks like beyond varsity. What you should look forward to. Does work feel like play? Well, not every day, but the good news is there are days that make it worthwhile. You are a production engineer first, design engineer second. Production comes first. The bottom line is your most important job. Everything else can wait. Yes, that exciting project you are working on takes a back burner when the plant is not churning out tons. Time at home with your partner and kids? You better ensure the plant is running okay. Yes, long hours are your reality. Standby becomes life. Is it fun? Yes. You, as the process engineer, are literally the middleman, the bridge. You are first contact with the production team, that is the foremen, operators, field workers. You guide, you coach, you communicate production plans. Management wants to know what went wrong, you better have an answer. How did the plant produce more tons last night? The big boss will want to know. Making sure you have an answer before morning meetings is your priority. Are you a shy person? Make more friends today. Talk more. Practice presenting your ideas. You will be heading a lot of meetings. The business of design. What is design by design? In this presentation, I will be doing a mock design of an ethylene production plant to give you, the student, as real an experience as possible. Hence the term design by design. I will be presenting the following: the design basis, the concept development via manual balance calculation, process simulation, presenting assumptions and optimizations taken to get to the final simulation, process flow diagrams, showing you the difference between a simulation process flow diagram and a process diagram that is used to represent the plant. Now, let's talk about fixing the design, the constraints of a design, the design basis. When doing a varsity project, most of the requirements for developing a design basis are given to you. For example, the tons required, operating hours in a year, quality requirements, raw material specifications. In the example to follow, I will try to show you how to develop a design basis without being given the above mentioned information. But first, what is a design basis? Well, the design basis is a document that fixes the constraints of the project, some of which we mentioned earlier, your tons per year. It combines the client's requirements with assumptions that will ultimately define the project. How big will the plant be? How will raw materials be delivered and stored on site? Process units can be defined using the design basis. It allows for the development of the conceptual design. It is literally a policing document that ensures that the design follows a well-defined path. Any deviation to the design basis must be communicated to the client, and the design basis must be updated. Now let's move on to a couple of examples of what appears in a design basis. Alright, so first one we're going to look at is the scope of work, right? It is required to submit to the client a detailed design of a plant that will produce 80,000 metric tons per annum of ethylbenzene, also known as phenylethane or ethylbenzone. Ethylbenzene has a chemical formula as shown, is an alkyl aromatic compound, which is extensively used in manufacture of styrene. Alright, so why 80,000 metric tons? A market analysis was done checking the feasibility of having the plant in Guyana. So in order for the plant to be viable, the plant must have styrene production, for which the ethylbenzene capacity must be set. Basically, styrene anchors the aromatics value chain and enables downstream integration. Simply put, it allows for increasing profitability by widening the value chain. In other words, having secondary and tertiary products will fetch a higher price locally and internationally. Now, let's go on to design assumptions and constraints. Most important part of the design basis, this one defines product quality required, reactor conditions, etc. It defines the standards that must be adhered to in the design to meet the market requirements, right? Your SANS, your ISO, and the reason for this is that certification of your product will require adherence to the required standard. So the design must be done in such a way that you will be able to meet those standards. This is the section that fixes the constraint of the design. It defines the concept. Parameters set here will be used for the material balance. Now, let's look at utilities. The utilities you have play an important role in determining what you can and cannot do. Without natural gas, for example, you cannot run the furnace required to produce hot air to heat up your reactor. Without refrigerated water, certain cooling processes won't be possible. Optimizing the use of utilities will play an important role in the profitability of your plant. We've come to the end of chapter 1. What should you look forward to next? Next, we will do the conceptual design. That is manual material balances, simulation, process flow diagrams, and the stream tables. So, do not know where to start with your design project? I offer one-on-one tutoring. Sessions are all done online using Teams or Google Meet. For as little as 450 per session, 1 hour per session, get personalized coaching. Master process simulation. Understand process conditions, assumptions, and parameters used for equipment selection. Learn the difference between simulation process flow diagrams and actual process flow diagrams used to present your plant. Become more confident in the way you approach process design, both at work and at school. Contact me today. Let's talk about a program that will work for you. My number 074 221 2766. Thank you for your time. I look forward to meeting each and every one of you.